This is video number 3 for lesson 6-6. At the top, I have a reminder here, or in your notes is a reminder of these properties that we practiced in 6-5, where if you're adding two logs, you can combine them into a single log. If you're subtracting two logs, you can combine them into a single log. And if you have a number multiplied by a log, you can combine that into a single log. That's the one where that hops up and becomes an exponent. And in 6-5, when we did this, we said we're doing this to get ready for when we're solving problems. So that's these problems. So if you look at this, I need to solve. It does not look like the ones we had on the previous page where we just had a single log on both sides of the equal sign. In this example, we have two logs subtracted, and then we have a single log on the other side of the equal sign. So what we want is a single log on this side of the equal sign. So it says combine left side into a single log, use the properties. So if I have two logs that are subtracted and I want to combine those, that's going to become a single log base 2. And remember, subtraction becomes division. Excuse me. Right side of the equal side, that's just a copy. Don't change anything. Now, two logs on either side of the equal sign with the same base means I can ignore the logs and set what I'm taking the log of equal to each other. So I have this. Now I need to solve for x. So if I'm trying to get x alone, I have x divided by 5. To undo division, I want to multiply both sides of the equal sign by 5. So over here, I have 5 on the top of my fraction, 5 on the bottom. That divides to give me 1. So I have 1x, or just x, equals, I think that's 625. Okay? So let's look at another one. This looks like a single log on each side of the equal sign, but you gotta be careful. This has that number multiplied in front of the log. So that's the power property. It says if you have a number out in front, it's gonna hop up here and become an exponent. I do this right here on this step. So I'm gonna move this 2 up here. This is gonna become log 3 of x squared. And then that 2 is gone. Now I have log on both sides of the equal sign. They're both base 3, so I can think about ignoring the logs and just setting what I'm taking the log of equal to each other. So x squared equals 16. To get rid of a power of 2, I take the square root of both sides. If I square root x squared, I get plain old x. When you square root both sides, you have to remember to add that plus or minus, because this 16 could have come from 4 times 4, or it could have come from -4 times -4. The square root of 16 is 4, so my answer is 2 answers actually, plus or minus 4. And most of the time when we're starting with an x squared, we're going to get 2 answers. All right, I want you to try these two. I'm going to tell you those should be your answers when you're done. So this is subtraction. Remember, first step, combine these into a single log using the properties. This is subtraction, but I'm going to warn you, you also have a number out front. So you're going to use 2 properties here. You're going to use the power property first, and then you're going to use the quotient property. So the power property takes care of that 2 out front. The quotient property changes subtraction into division, or a quotient. Now, the one on the back, I need you to make a change in your notes. It said base x, it should have been a base 3. So the first thing I want you to do on this one is rewrite the problem with a base 3. Now I want you to pause the video here and do the first step where you rewrite it as a quotient because you have subtraction. And so after you've done that, you should have this without the arrows, but you should have log 3 of x plus 5 divided by x minus 2 equals 3. Now the reason I wanted to give you a hint on this one is you have to be careful. This isn't a log on both sides. This is a log on one side and a number on the other. So these are the ones where we rewrite them as an exponential. So that's why I have the arrows. So the process for solving these, log on one side, number on the other, is rewrite it as an exponential. Remember, the x's are trapped inside the log. The way we get them out is rewrite it as an exponential. So pause this video, see if you can finish this problem. And then I have, hopefully you tried it, but this is a kind of a long problem. So I'm going to show my steps here. This is my rewrite. And to undo the divide by x minus 2, well, 3 to the third. Oh, shoot, I made a mistake on here. 3 to the third is 27. To undo divide by x minus 2, I need to multiply both sides by x minus 2. I'll just redo this since I had a mistake in it anyway. So on the right side here, x minus 2 divided by x minus 2, that's gone. That's why we did it. Divides to give you 1. And on the left side, I'm actually not going to have this. Let me cover that up. I'm going to have 27 times x minus 2 equals x plus 5. Then I need to distribute this 27. I'm going to have 27x minus 27 times 2, I think that's 54, equals x plus 5. I'm doubting myself, so I'm going to quick check that in a calculator, although I'm pretty sure. Yeah. Now I have x on both sides of the equal sign, so I'm going to minus x from both sides. So I'm going to get 26x minus 54 equals 5. Because that adds to 0. Now I'm going to add 54 to both sides. 26x equals 54 plus 5 would be 59. Divide both sides by 26. X equals 59 over 26. Let's see if that can be reduced. Put it in the calculator here. 59 divided by 26 equals, and then math, enter, enter. Nope, cannot be simplified. So you can leave it like that, or you can put the fraction, which the fraction was right up there, 2.27, or x equals 2.27. Okay. That is it for 6-6.